Rafal, and I'm speaking to you from Poland, from Krakow, and I would like to tell you about 5 levels of high availability from multi-instance to hybrid cloud. But at first, a few words about myself. So I'm a cloud software engineer at Hazelcast. Before I worked at Google and CERN, and I'm also an author of the book Continuous Delivery with Docker and Jenkins. And from time to time I do conference speaking, but my main job is programming. A few words about Hazelcast. So Hazelcast is a distributed company, and it is distributed company in 2 meanings. So first meaning is we are distributed company because we produce distributed software. Our products are the best known is Hazelcast, which is an in-memory data grid used for caching or in-memory storage. Second product is Hazelcast Jet, which is a library for stream processing. And the third product is Hazelcast Cloud, which is Hazelcast put as a service. But there is also a second meaning of why Hazelcast is a distributed company. And this meaning is because we all work remotely. So it was at the beginning and the founding of the company, it was a remote company. So we have people from all over the world. Our agenda for today is pretty simple. So there will be a short introduction about high availability in general. And then I will walk through all high availability levels you can use in your system. While I'll be talking, I would like you to think about 2 things, to think about 2 questions. So the first one is your system, your current system you are working on which high availability level is it deployed? And the second question is, would it be easy for you to upgrade to any higher availability level? How difficult would it be to change the architecture of your system to work on higher availability level? And with these questions, let's move to the content of this talk. So the introduction. So in the center of every system currently, there is a service. We call it a microservice. Sometimes we call it a microservice, even though it's a very big in terms of the code. But it doesn't really matter if it's a microservice, macroservice, or a Lambda function run on the serverless architecture. The thing that is important here is that this service is stateless. And stateless things are easy. Stateless things are, just imagine that you build your system only with stateless services. So you have no problems with anything. If every service of your service would be like a calculator service that just adds 2 numbers, that does not have any state, then you could deploy it anywhere. You can deploy it the same on your laptop and the same on any machine. It works exactly the same. So no problem with high availability or scalability. But that is not how the real world of an IT person looks like. So in reality, every stateless service is connected to some data store or some caching or a queue or some other service. And these other things usually have some state. And this data is the problem here in the context of high availability. That is why, while I'll be talking, I will always give you the whole architecture, the whole diagram. However, I will focus on the data part, since the service layer is usually the easy part in terms of the high availability. And with this context, let's move to the level 0, which means running everything on a single instance. A diagram for this would be like, it may resemble your development environment. So you run everything on your laptop, your service, your database, and then the request goes to your service. It uses the database located on the same machine. Everything is simple. You may think like, but what kind of cowboy software developer would use a system like this? It's not, in modern times, you never build something like that. But remember that not everything needs to be highly available. Just think about an independent batch job that you can repeat anytime. So that it doesn't need to be highly available. So there is still a place for like level 0 single instance in the IT development. And what is good about running everything on a single instance? So it is very simple, and also the latency is low. I did a latency experiment running Hazelcast in an application and doing read-writes to a Hazelcast database and checked the latency. And the result was like 80 milliseconds per 10,000 of entries. Obviously, we don't have the context. We will later have the context of other high availability levels, but you can already see that it's very, very low, which is expected. You run everything on your one machine, so why should it be high? So, and this is something that will be higher in other levels. So what does it mean like level 0? What does it mean to you? Obviously, you are not highly available, you have no scalability, but on the other hand, like latency is very low and your data is consistent because you use only one instance. And this consistency, it is something we will partially lose while we go up with our high availability levels. Okay, but you didn't come here for listening to some single instance deployments, so let's move on and talk about multi-instance. So multi-instance means that if one machine is down, your system is still available. A diagram for this looks like that. So a request goes to our system, it goes to load balancer, which load balances the traffic across multiple application services which are deployed on multiple machines, and these application services, they use data store which is also located on multiple machines. If you look at this diagram, there is only one thing that is single on this diagram, and that is a load balancer. However, we will not speak a lot about load balancing because this problem is kind of solved. You can use some DNS based load balancing or some very reliable load balancer from cloud providers, so we will not talk about load balancer here. We already mentioned that the stateless part is simple, so we will also not talk about services. We will talk about data. So our assumption for the data stores are we have at least two data stores located on two separate machines, which are located in the local network, which is fast and reliable. If you would like to have like to see like what would be the example, just run two EC2 instances on AWS in the same zone, in the same region. That's your deployment. Usually a data store, this will be the data store. This is actually the real data store from the CERN in Geneva. By the way, if you happen to come close to Geneva, go to CERN. You can go there for a free tour and see not only data centers, but also these colliders and everything. It's super interesting. So if you happen to be there, just don't hesitate to go for a free tour to the CERN. Going back to our instance, so to our data stores. So we have two instances of the database, and we need to make them the same, like the data make the same. So we need to actually do something what is called data replication. And now let me tell you a short story, a short history actually of the data replication, how it was created. So you remember like the SQL databases were like the most, that was the way you build your environments. And most data SQL databases used and still use active passive replication or master slave, meaning that application services, they use only one instance of the database, and the data is copied to the second instance, which is passive or read-only. And now, no problem with the consistency, because we use only one instance. And now, like, if this machine 1 fails, if it crashes, then we fail over our services to the machine 2, to the second instance, and we don't lose any data, no problem. You can obviously improve it, like with some sharding for the performance, but that's basically the idea how even now when you use like a SQL database, how you will replicate your data. But now, when there was this movement of NoSQL, people said like it's not good enough in terms of performance. Like this copying the whole database events, it's just too much. So we need something better. And like NoSQL was kind of a simpler in terms of database, so it allowed a little better data replication strategies and data access strategies. So currently, like most NoSQL databases, they use what is called clustering. Clustering means that application services, they have connections to all instances of the database, and each of the instance stores part of the data and backups of the other parts of the data. That's why if one machine is down, you can still restore the backups of the parts of the data and not lose the data. To go a little deeper, how it looks like, let's see an example of Hazelcast, which use clustering. So let's say we have three Hazelcast instances, and each of them stores part of the data. So the data is partitioned, and each instance stored, like let's say member 1 here stores partition 1, 4, and 7. Now the rule here is that the backups of these partitions are always stored on another member. So the backup of the partition 1 is stored on member 2, the backup of the partition 4 is stored on member 3, and the backup of the partition 7 is stored on member 2. So in case member 1 is down, we can promote the backup data, restore the backup data, and not lose don't experience any data loss. And that is the idea, like how all these NoSQL databases, how they work. So they partition the data, you access all the cluster, and from your application service, you just use the cluster of your databases. Now the question you may ask, like at this point, like in both cases, this master-slave replication and this clustering, should we do the backup synchronously or asynchronously? In other words, should we favor consistency or should we favor latency? And you can think for a moment, like if you were to give your money, how you would design, like what is the right answer here? And before I answer this, let me do another latency experiment. Let me show you the result of latency experiment I did with Hazelcast. So I've set up 3 Hazelcast instances on 3 machines and on AWS, and I measured the read-write latency again. And I measured this for the case when the data was consistent. So we did synchronous backups. And the result for this was like that. So it took 3000 milliseconds per 10,000 of entries. So obviously it's worse than single instance. No question here. So, but 3000 milliseconds per 10,000 entries, it's still less than 1 millisecond per entry. So it's usually acceptable. That is why in most cases, for the clustering, you will, by default at least, use synchronous backups. Because because like using consistent data cluster is way more easier for application developer and way more clear than using the non-consistent cluster. That is why in most cases, if you use multi-instance, use NoSQL database, you will use synchronous backups. But you can still configure this if you would like to favor latency. Will it be the same for SQL databases and for master-slave replication? Not necessarily. Like, for example, MySQL, by default, they use asynchronous backups because it is just more complex, so it takes more time. That is why they decided by default, you can configure this, but by default they use async backups to favor the latency here. Okay, a short summary. What does it mean multi-instance for you? So, good thing is that you can still have the data consistent across your database instances. Most tools support it. That is good. Cloud-specific toolkits, they're mostly supported, and the setup is very simple. Even if you would like to set up on premises, like let's say Hazelcast on premises on your server, the configuration is super simple. From the downsides, if you set it up, your cluster is located in one local network. So if you access this from any other place, the latency will be high. So if you set up your cluster in Europe, in your local network, then you want to access your data from US, the latency obviously would be high. Okay, let's move from the multi-instance to multi-zone. So multi-zone means that if one availability zone is down, your system is still available. An availability zone is usually a few data centers. This is a photo actually from Facebook. These are data centers that are connected to each other and they are independent from other availability zones. Independent, I mean they have separate power supply, so if there is a power outrage, then you don't have any problem. And usually you will see if you go to AWS, GCP, that you have usually in the close area, like in one town, and different places in one town, you have multiple availability zones because they have still to be close to each other, but they need to be independent, like in the terms of natural resources. The diagram for this would be like that. So again, a request goes to load balancer, it load balances the traffic to applications services. Now application services needs to be located in multiple availability zones, and the same with the database. They need to be in at least two availability zones. So you may ask, this diagram looks very similar to multi-instance. So is there actually any difference if you deploy to multiple zones or multiple instances? And I would say no, there's not much difference, but there are some differences. To understand why, let me first tell you why no. And I did a latency experiment again. This time Hazelcast instances were deployed in multiple availability zones, and I checked the latency for read-writes. And it was obviously a little worse than multi-instance, but it was not much worse. It was not even twice worse. And the latency is still less than 1 millisecond per entry, which is relatively good, which is usually acceptable. That is why I said no, it's very similar to multi-instance. However, there are some differences. So let me to explain you what is the difference for multi-zone. Let me give you an example here. So this is let's say we have four database instances located in two availability zones. It can be on EC2 instances in AWS in two availability zones, for example. The network between availability zones in cloud providers is usually availability zones, they are connected with the instances in an availability zone. They are connected with dedicated networking, so the network is fast and reliable. And to understand like the problem here, let's go back to this slide. So you remember, like, we had Hazelcast, we had 3 instances, we we partitioned the data. The rule here is that the backup is always on another member, so that if one member is down, you can restore the data. So far, so good. But now imagine what will happen. We have a setup like this. So we have 4 Hazelcast instances located on 4 machines, 2 in one zone, 2 in another zone. And now we have one partition marked as yellow, and the backup of the partition is on another member. However, both of the members happen to be in the same availability zone. Now, if the zone 1 is down, obviously we lose the data. So this is definitely not something we would like to experience. So we thought how to solve it in Hazelcast, how to address this problem. And we came up with the idea of the zone aware feature. You enable this like this, put this into your Hazelcast configuration that you would like to partition by zone, keeping zone aware. And now, how does a member knows about the zones? Because like availability zone is a concept which is separate for each, which is different for each cloud provider, for each environment. This is the concept from the cloud providers. So we came up with the idea of the plugins. So we have a lot of plugins in Hazelcast. They are also used for discovery, but they are also used to fetch the availability zone that Hazelcast instance is located in. So you run on AWS, use AWS plugin, Hazelcast queries using AWS plugin queries AWS API to check, okay, in which availability zone I am located. And then Hazelcast cluster knows how to distribute partitions and the partition backups so that each partition backup is always located in a different availability zone than the partition itself. In result, we always have the backup of the partition in another zone. So in case of any zone failure, we don't experience any data loss. So that is why I said no, there is no difference between multi-zone and multi-instance, but there is some difference. And the difference is that you have to make sure your data store supports zone aware feature. And don't take it for granted, because we spent some time implementing this feature, so it's not obvious that everyone thought about it. So just check if your tool supports it. Short summary of the level 2 multi-zone. So currently I would say this is the top 1 choice, because you can still have the data consistent, but you are very high available, because it's very rare that the multiple zones fails at the same time. You can use some cloud-specific toolkits, like for example AWS SQS. It works fine. From the downsides, if you are still in one region, so if someone uses your system deployed in one region from other regions, obviously latency from other regions will be high. And also make sure that the tools support a zone-aware feature. Okay, we covered multi-zone, so the next level is multi-region. Multi-region means that if one region is down, your system is still available. And the diagram for this looks like that. So we have a geo-load balancer, which load balances the traffic, taking into consideration the geolocation. And in each region, we have the same environment with application services and with our data stores. And between the data store, we have something called geo-replication. So to focus on the data, our assumption is that we have machines in at least 2 geo-regions, and the network may be slow and unreliable. because even the connection between the network may be connected via like public infrastructure, so it's very unreliable. As an example, we can have EC2 instances in two regions like Europe and US. Now, let me tell you what is really the deal like with the regions? Why region is a problem? We need some geo-replication and so on. So the thing is that the physical distance is the problem because the regions are just far away from each other. Let's take like Finland and Oregon. These are two data centers in Google Cloud Platform. So the distance between them is 10,000 kilometers. So even if we just take into consideration like speed of light in a vacuum, the round trip time would be 60 milliseconds of one signal. And it is a speed of light in a vacuum. So if you take the speed of light in the fiber, it's even worse, like at least 3 times more. So we have like 200 milliseconds, and it's just one ping. So it's the physical nature of the light is the problem here. That is why we need this geo-replication. Geo-replication means that we synchronize data between two geographical regions. And what is special about geo-replication? So the geo-replication, because of the physical distance, it needs to be asynchronous. Your data store must support it, and you must be prepared for the data loss because it's asynchronous. And the geo-replication usually works in two modes: active-active and active-passive and active-active. When you use active-passive, one of your cluster is read-only or just disabled. And you use just one of the cluster, and it just copy the data asynchronously to another cluster. You must be prepared for the data loss because it may happen that you wrote something to your active cluster and it's suddenly down, so it didn't replicate the data yet, so you experience data loss. That is why also you need to be prepared for the eventual consistency. And in the case of active-active, it's even worse, because then you can read-write to both of the clusters, so not only you can experience data loss, and you have to be prepared for the eventual consistency, but also you have to think about config resolution. Because what will happen if you change the same data at the same time in two different clusters? Which one is the correct one? And that is one in most of the databases, like what we do in Hazelcast. You can define your conflict resolution strategy that will be applied in case of the conflict. The basic strategy is like first one wins or the last one wins, but you can have some more complex conflict resolution strategy, because you as a developer, you need to decide like what should happen if conflict occurs. And some databases, I think like Couchbase, I think they have like they do it differently, like they store all the config tree in the database, and then you as an application developer, you need to take this tree and decide about the config resolution. In Hazelcast, we have geo-replication, obviously, and we call it one replication. The configuration for this is very simple. Like you define a configuration like what you see here at the bottom. You just specify, okay, I would like to asynchronously copy the data to another cluster, and with this IP address, and that's it. Now you may wonder, like, but do I really need to lose consistency? What if I have like I don't know, a banking application for the transactions? What to do? So I did another experiment. I've set up Hazelcast cluster with one cluster across multiple regions. So one consistent cluster across multiple geo regions. And check what was the latency. And latency here was like that. So you see it's it's unacceptable. It's so high that it will just kill your performance. That is why you will not see any like consistent cluster across multiple georegions. Obviously, I also did it with the proper way, like with the geo-replication, with the one replication, and the latency was the same as multi-zone because we did all the sync events asynchronously. Now, what you see here is also the reason why you will never see a Kubernetes cluster deployed on multiple regions. That is the same reason, because underneath Kubernetes uses etc database, and this database it needs to be consistent across its instances, so it cannot be deployed across multiple regions because it would kill the performance. If you like really need to have like banking transactions, distributed transactions, and so on, I recommend you reading about something called NewSQL, like the Spanner database from Google, or its open source version, which is called CockroachDB. But even if you use them, you will still have this trade-off between consistency and latency, and you will never escape from that. Short summary of the multi-region. So multi-region means you are super high available and you can have low latency if accessed from multiple regions, because you can deploy your system in multiple regions. But from the downsides, you need to use geo-replication, which is asynchronous, and that is why you need to be prepared for all this nasty stuff like eventual consistency, config resolution, and it's basically getting way more difficult here. Okay, let's move from multi-region to multi-cloud. So multi-cloud means that if one cloud provider is down, your system is still available. And the diagram is like that. So we have again like a global load balancer, which load balances the traffic across multiple cloud providers. And in each cloud provider we have the same system, and the data stores are replicated like a geo-replication we've seen before. An assumption here, like we have machines in at least two cloud providers. Obviously the network again may be slow and unreliable. It's even worse here because technically some cloud providers I think now offers like dedicated networking between their regions, but you will never have it between different cloud providers. And you may ask here like, so do I have any differences between multi-region and multi-cloud? And technically you still you need to use the same like geo-replication. So this is the same. However, there are some differences, like you cannot use now cloud-specific tools. So if you used before, like I don't know, Elastic Cache, now you have to deploy it yourself because the Elastic Cache is only on AWS, but you don't have it in GCP, and so on. So let's say instead of Elastic Cache, you need to use Hazelcast or Redis deployed deployed on your own. Also, you don't have VPC peering across different cloud providers, so it will affect your latency and security. And also the cost will be way higher. So is the high availability the only reason for multi-cloud? Obviously no. I would say usually it's not the main reason. One of the main reasons I see is, or we see as Hazelcast when we're working with our customers, like enterprise customers, what they want to do is to avoid vendor lock-in. Meaning they don't want to be bound to only one cloud provider. Because it is all about risk mitigation. If you put all your money for AWS, then suddenly AWS increases the prices or changes their policy. It's very difficult for you to change to GCPs. That is why you can start upfront from multiple cloud providers, and then you are safer. Also, you are in a better position in the cloud cost negotiation, because obviously the price the big enterprise pays to AWS is different than what I would pay to AWS, because they negotiate the cost of their machines. And when they negotiate the cost, they are in better position if they say, oh, by the way, we are already deployed to GCP, so AWS, what would be the price from you? One other reason is low latency. If you would like your system to be accessed from multiple cloud providers, because if the consumer of your system is deployed on GCP, you'd better be on GCP. But if you have multiple consumer on different cloud providers, then you would like to be in multiple cloud providers by yourself. Also, like some other reasons were like data protection, regulation, compliance. This is so something like not from the technical background, but it goes from the business requirements. And also like best fit technology. If you build not homogeneous environment, but some heterogeneous environment, then you would like to use some specific cloud portfolio. Like you need Spanner from GCP, then you use GCP, and the rest you use from AWS. Short summary, so multi-cloud, no vendor lock-in, you are in better position for cloud cost negotiation, and low latency if accessed from multiple cloud. From the downsides, the setup is very complex and you cannot use like cloud toolkit, but you have to install everything on your own. The last level I would like to mention is hybrid cloud. Hybrid cloud means that if all cloud providers are down at the same time, your system is still available. You may see like, really? Like, is it possible that all cloud providers are down at the same time? And obviously no, it's not possible. So it's not, high availability is not the reason for hybrid cloud. There are some other reasons, like the main reason you will see or we see in our customers is some data requirements. Like there is a bank and the requirement for the bank is that they store the data of their customers in this building, in this country, in this building, and on these servers. Then you need to have a hybrid cloud environment. Another reason, like data security, it goes together with this regulation and requirements. Another reason, like, is that you currently are on premises, but you are moving to the cloud. So as the phase in between, you can have hybrid cloud environment. So hybrid cloud, you have another, again, like load balancer, which load balances the traffic to all your cloud-based environments, but also on your on-premises environment, so you keep your own infrastructure as well. At this point, or even at this point of multi-cloud, you need some abstraction layer. So because it's just not possible to manage like servers, like each server separately. So you need some orchestration layer, which nowadays is usually Kubernetes or some derivatives of Kubernetes like OpenShift, IBM Cloud. This is what we see, like all our customers, they install this layer. Some of them uses like Cloud Foundry, which is now renamed to VMware Tanzu. Some old customers, they use Mesos. But basically now I think like Kubernetes is the way most people go. Short summary, so hybrid cloud, there is no vendor lock-in. Low latency can be from any custom network because you can deploy your system anywhere you want. However, the setup is very complex. You need this layer of Kubernetes or any abstraction layer, and it usually costs a fortune. So like this, we covered all high availability levels. As a short summary, what I prepared as a short summary is a graph how I see the cost and the complex of your infrastructure compared to different high availability levels. So I see this as that. Like the simplest is single instance, no problem here. If you go to the multi-instance, suddenly your system becomes a distributed system, which is way more difficult. From multi-instance to multi-zone, it's a small step actually. Just make sure your data store is zone aware and you'll be fine. However, from multi-zone to multi-region is another big step, because now you have a long distance, so you have to do geo-replication, which is very difficult because it becomes, your system becomes eventual consistent. From multi-region to multi-cloud is another big thing, because you cannot use cloud toolkit. And from multi-cloud to hybrid cloud, it's another very big step, because suddenly you are maintaining your own infrastructure. Which high availability level is for me? So I would say, like, if you are not sure or you just want to build a system, then this is your level. This is top one choice, because in multi-zone your system can still be consistent in terms of the data, but you are very high available. So it's probably the best way to go. If you are a software cowboys, just use single instance. Multi-region is basically if you need your system to go worldwide. And multi-cloud, hybrid cloud is for big industries with the hard data compliance, regulations, and so on. And if you have a lot of money, that you may invest into that. And with this last slide, I would like to thank you for listening. It was a pleasure speaking to you from my home, from Krakow.
Hello. So that was Rafal with the 5 levels of high availability. And Rafal, are you here with us?
Yes, hello. I'm
Hello,
here.
hello. So that was a great speech, so informative. And we have some questions from the audience. So I will give you the first one. And there's a lot of confusion on how the traditional ACID database model fits to nowadays multi-cloud setups. Is it really surpassed, and what requirement can you override?
So yeah, so the ACID model, like the traditional relational databases, they don't fit well in this multi-cloud or even multi-region scenario, because basically of the distance, but basically because of the public network they need to pass. So I would say like that, if you need like the transactions, there are distributed transactions, so you can check them, but it will always be in terms of it will always be a trade-off between latency and consistency. Between the distributed transaction will be it will take time in other sense. So that's but obviously you can have it. The distributed transactions, they exist.
Okay. Now, and the next one, doesn't multi-cloud add a risk for development's perspective that need to know all techs and make up all different setups work?
Yes, they add a lot of complexity. So they also add a risk for developers to manage this complexity, and to that's why I mentioned that you need this additional layer at some point, that at multi-cloud is this point, that you need this Kubernetes just so that it will be manageable. But yes, it makes your system much more complex. So multi-cloud is not something always better than multi-region or multi-zone. It's not always something better. Yeah.
Okay, and can you tell us what kind of tests do you run in your high availability environments? Do you have in Hazekal's your own service availability solution, or are you using?
Yeah, I mean, in terms of the tests, with Hazelcast, when we deploy like high availability, we have to talk about one of our products, which is Hazelcast Cloud. This is like a Hazelcast as a service. So we built our system, and then we have a lot of different kind of tests, like like standard integration test, like obviously deployed on on multi-cloud, but it will be standard integration test, but nothing like special that you won't find anywhere, like the penetration testing, like the performance testing, etc. So this is like this is the standard thing.
Okay, so thank you very much. Thank you, and just I don't know if how did you experience now the online conference? Was this your first time, or are you now used to due to what we have been through the last months?
Yeah, I'm already used to. I mean, I did a lot of virtual presentations nowadays. For me, it's more difficult because you don't, you know, you don't have this contact, this direct contact with people. But it is as it is, you know. We are in the
Yeah.
now everything went online, so then there's nothing we can do. But I
Yeah.
can't wait until I start travel again for the conferences.
So you were working remotely before or now?
Yeah, I was working remotely for a long time, but about like the conference speaking started this year actually, the remote conference speaking.
So, our last question is, can you give us some hints to the young IT students which tech to learn so as to be up to date regarding cloud?
Yeah, that's a very difficult question because then it will depend what you would like to specialize on. Even like we are a small company and we have people like who are very deep into Java, who are very into cloud. But nowadays, I think cloud, if you would like to really go into the cloud development, then I would say Kubernetes and Golang. That's the mainstream, like Kubernetes with Golang and some other enterprise language like Java, Kotlin, or something that would be the good start. But you know, the cloud stack is like there are so many things now. If you look at, I think also a good, like what I would suggest, you can look at this cloud native foundation. There are a lot of projects there. You can look at they have even a diagram of all projects included in the cloud native foundation, and then there you can choose from there.
Okay, so that's all. Rafal, thank you very much. Thank you for having giving us the opportunity to see your work, and hope next time, next year, that we will have a physical conference and you join us.
Hopefully, can't wait for this.
Yeah.
Thanks for having me.
Thank you, Rafal.